Hello everyone, this is Saikat Shome, Assistant Professor in the Department of Civil Engineering, Haldia Institute of Technology. I have done my BTech and MTech and right now pursuing PhD in this field of civil engineering. Today I am going to deliver a lecture on stabilization of black cotton soil. As you all know, the black cotton soil has some problem regarding in this field of construction. This in the construction of the black cotton soil, we have some swelling and shrinkage problem in the black cotton soil. So we need to stabilize this black cotton soil actually. So black cotton soil is a kind of a montmorillonite structure of soil which has the tendency of absorbing water in its intermolecular particle, so it has the tendency of absorbing more water, and for this problem it has some affinity to swell and shrink during this construction processes. So we need to stabilize this black cotton soil. In the many range many parts of India we have got the black cotton soil. So for the construction over the black cotton soil we need to stabilize, we need to fix this problem actually. So this topic is on the basis of the stabilization, how we can stabilize the black cotton soil to prepare a construction over it. Okay. So the overview of this black cotton soil is presented in this slide. This is characterization of black cotton soil, objective of its stabilization, the method of stabilization process, advantages of stabilization, and conclusion. The stabilization process, as we all know, stabilization means improving the internal property of a soil, internal property of a soil, like it is increasing the bearing strength, increasing the pore water pressure, and increasing its few parts of this black cotton soil. So we need to stabilize this actually. So the next thing is this is the pictorial representation of this black cotton soil stabilization. As you can see that this soil is a black in color, actually black in color, and that's why it is named as a black cotton soil actually. So this is the introduction part, and this is the black cotton soil. It is also known as the expansive soil. It is expand, accordingly it is expand and poses some significant challenges in the construction due to its swelling and shrinkage properties, as we already mentioned. The high clay content, primarily the montmorillonite particle. It causes the soils to expand during in wet season and shrink during its dry season. Okay, so this leads to crack in the structure and build on which the on or with this soil. If we construct any construction over it, it has the tendency to crack during this process. So it need to address these issues. For the stabilization method are employed to improve these engineering properties, making it suitable for the construction. So this is actually the thing, this is actually the focus, this is actually the point where we are going to deliver the lecture on this topic, actually stabilization of black cotton soil. So that these are the characteristics, that is it has the high plasticity. Black cotton soil has a high plastic in nature, which makes it highly compressible and capable of retaining a significant amount of moisture. Montmorillonite clay has a tendency to attract the soil particles. Actually, it has the high affinity to contain of the soil, the water content or the moisture content. Okay, as the moisture content enters into the soil particle, it has the tendency to swell and shrink during its during the different kinds of the season. Due to its expansive nature, it swells when it is dry, and the repeated cycle causes cracking and differential settlement. Bearing capacity: black cotton soil has a poor bearing capacity and making it unsuitable for the direct use of the construction. Okay, and for the construction of the building, for the construction of the roads and other infrastructure, it has a unsuitable condition to construct over a black cotton soil. So we need to address this issue before construction of on to the black cotton soil. The objective of this stabilization process is that improve its load bearing capacity, minimize the soil's tendency to swell and shrink, enhance its durability and strength, make it suitable for the construction activities like road laying, foundation building and more. Okay, so these are the objective of this stabilization. Objective of stabilization, first of all, we need to address the its physical properties, like the black cotton soil has a very low of bearing capacity, so we need to address this. It's minimized to tendency of the swelling and shrinkage, and it has the enhance its durability and its strength, make it suitable for the construction activities. If we do not address this stabilization process, so if we do not address these properties, we cannot construct over it. So we need to address this bearing capacity, swelling and shrinkage tendency, and durability and strength properties. So this is the main objective of this stabilization process. And these are few methods of stabilization. The methods of stabilization is that the first one is the mechanical method of stabilization. Second one is the chemical method of stabilization. Third one is the geosynthetic method of stabilization. Fourth one is the bitumen method of stabilization. Fifth one is the thermal method of stabilization, and sixth one is the reinforcement technology. Soil reinforcement process is the method of stabilization. And first one is the mechanical stabilization. Mechanical stabilization means we are going to stabilize the soil with the help of any mechanical properties, like we are using the roller. This is a mechanical thing. Roller is a mechanical thing. We are using the roller to stabilize the soil. This is a normal stabilization process. We used to see this in any road construction also, any soil. So this is the mechanical method of stabilization. Mechanical method of stabilization is a process where the physical means are used to enhance the properties of the soil, making it suitable for the construction and other engineering applications. Physical properties and the physical mode of use of any material, that is called the mechanical properties. This method is typically employed to improve the soil load bearing capacity, reduce its plasticity, and increase its stability by altering its gradation, compaction, and moisture content. Using the roller, we are using this compaction method. So this is the main objective of this mechanical stabilization. Okay, the procedure is this: the soil is mixed with a selected proportion of the coarse aggregate, compacted and thoroughly, and then its bearing capacity of the soil is improved. This is the mechanical method of stabilization. This is the application is that the road construction, we can use it in the mechanical stabilization method. We can use it in the road construction. We can use this in a foundation construction. We can use in the embankment and dam construction. We can use in the airfield and railway construction. All these fields we can use the mechanical stabilization method. Mechanical stabilization is extensively used in the road bases and subgrade. As you all know, we have the flexible pavement have the 4 layers: subgrade, subbase, base, and wearing course, and the rigid pavement has the 3 layers. Okay, so the mechanical stabilization extensively used in the road base layer and the subbase layer. Okay, stabilize soil properties, a strong foundation to prevent cracking or rooting of the soil surface. Foundation construction. In the building construction, mechanical stabilization soil ensures that the foundation rests on a stable and load bearing surface. Okay, embankment and the dams. For earthen structure like embankment, dams, or levees, mechanical stabilization is crucial in preventing settlement and erosion. Airfield and railway construction, we can use this mechanical stabilization process in the airfield and railway construction also. Okay, this is the pictorial presentation of the mechanical construction, mechanical method of soil compaction, mechanical method of stabilization. You can see that the roller, a 6-foot roller, is using in this base layer or maybe the subbase layer to compact this soil. This is the pictorial presentation of this mechanical method of compaction. This is the mechanical method of soil stabilization. The mechanical method of soil stabilization is that this is the granular method. This is a granular method. This is the compaction process. As you all know, the soil has the 3 layers of the soil. There's one is the solid particle, one is the air particle, and other one is the water. 3 layers. In the compaction process, the air is expelled out and the soil is gets compacted. This is the normal compaction method. As you all know, all the in the first chapter of geotechnical on the we used to know there is a soil has a three-phase system. This is the representation of the three-phase system. While compacting it, we are expelling out that air. So soil, in that cases, soil is going to be a two-phase system. One is air, one is water, and other one is the solid. This is the total whole compaction process actually. Mechanical method of stabilization has some limitations also. That limitation is the short-term durability. Unlike chemical stabilization, mechanical stabilization does not result in long-term chemical changes in the soil. Over time, the soil may revert to its original position. Okay, this is the normal case actually. If a rubber is stretched out, it is get back to its original position after some time. So the soil has also that same properties. Over the time, the soil may revert to its original properties if subjected to moisture or then environmental condition. Labor and equipment intensive if it requires heavy machineries and skilled labor for compaction, blending, and site preparation. This is a limitations also. In limited for the expensive soil. In highly expensive soil, mechanical stabilization alone may not be sufficient to prevent significant swelling and shrinkage. In the We are actually discussing about that the black cotton soil property. So the main thing is that for the expensive soil or the black cotton soil, only the mechanical stabilization is not enough. That is what the limitation is saying. Okay, the mechanical stabilization has some concluding. So we are concluding that mechanical stabilization method, that method is the mechanical stabilization is an effective and practical approach to improving soil properties for various engineering applications. This is the stabilization method. It doesn't suggesting that only the mechanical stabilization process is beneficial for the black cotton soil. Okay, this is just an overview of the mechanical stabilization process. Okay, so the mechanical stabilization we have already learned. The mechanical stabilization method has some limitations also. So the mechanical, it is effective and practical approach to improving the soil properties for various engineering applications. It provides an immediate solution to poor soil condition, enhances load bearing capacity, and offers flexibility by allowing the use of local materials. While it may not provide long-term chemical stability, it is an eco-friendly and economical solution for many construction projects. So this is the conclusion. This is the brief view of the mechanical stabilization process. Okay. So the next thing is the chemical stabilization process. We have already discussed how many types of the stabilization process we are going to discuss in this field, in this presentation. So this is another way of stabilization process. There is the chemical stabilization process. Chemicals in the mechanical stabilization process, the physical properties like ruler or anything we are using. The chemical stabilization process with chemical property as a external property is injecting into the soil. In this method, certain chemicals or the stabilizing agents are added to the soil to modify its properties. External material is approached into the soil to have to change or modify the soil properties. Okay, chemical stabilization involves adding of chemical agents to black cotton soil to alter its properties and improve its performance. Black cotton soil is notorious for high plasticity, shrinkage and swelling behavior, low bearing capacity. Chemical stabilization transforms the soil structure, reduces its expansive nature, and enhances its strength and durability. Common chemical which are used for the stabilization process. There is a lime stabilization process, cement stabilization process. These are the different kinds of stabilization process are there. Nowadays, lime stabilization and cement stabilization is a old method actually. It is an old method. So still now we need to know this method actually. Lime stabilization by the lime, cement stabilization, the stabilization by the cement. Lime is an external property we are adding to the soil. Cement is the external property we are adding to the soil. That's why it is called the chemical stabilization, where we are injecting some external property to enhance or modify the soil properties. Okay. Lime is one of the most commonly used additives for stabilizing black cotton soil. It reacts with the clay minerals and improves the soil strength, reduces plasticity and mineralizes swelling shrinkage properties. Okay, and the lime reacts with the water in the soil, causing the flocculation and agglomeration of clay particles. This leads to denser and more stable soil structure. This is the lime stabilization, and this is the photo at the lime stabilization method. Here the white part is the whole lime. Okay, lime is mixed with the soil and it is stabilized. This is the lime stabilization method. Nothing more than that. Only the lime is added to the soils to stabilize. Okay. Next thing is the cement stabilization process. In this figure also you can see that cement is adding in place of that lime. Okay, so this is the cement stabilization process. Cement can also be used to stabilize black cotton soil. It forms a hardened mixture binding soil particles together, which results in increase the strength and reduce the moisture susceptibility. Very simple thing. Chemical stabilization is a very simple thing also. Lime stabilization, chemical stabilization, nowadays fly ash stabilization also there. Any other material we can use to stabilize this black cotton soil, or any other kind of soil we can stabilize with this help of this lime and fly ash. Okay, what we have I have already said, it's a fly ash, a byproduct of the coal combustion. Fly ash can be added to the black cotton soil to enhance the bearing capacity and reduce its expansiveness. Fly ash reacts with the lime present in the soil to form the cementitious compounds that strengthen the soil. These all are the chemical agents that are used as the in the chemical stabilization process. Chemical additives, certain chemicals like sodium chloride, calcium chloride, and polymers are also used to alter the soil's physical and chemical behavior to reduce its swelling and shrinkage properties and increase the stability, increase the strength and durability also. So these are the agents which we can use in the chemical stabilization. We have already learned in the last slide, and these are the advantages of using the chemical stabilization. Okay, it reduces the swelling and shrinkage. Chemical stabilization drastically reduces the expansive nature of black cotton soil, minimizes the cracking and structural damage. It increases the strength. The treated soil becomes stronger, allowing it to support heavier load without excessive settlement. Improved durability. Stabilized soil is more resistant to environmental factors like moisture and temperature fluctuations. Versatile. Various chemicals can be used depending on its specific properties and project requirements. It also has some limitations like mechanical stabilization also. It has the cost. Chemical stabilization, especially with the additives like polymers, can more expensive than the mechanical stabilization. Okay, it also required the sufficient amount of the labor and the required skill to develop this stabilization process. It has some environmental impact also. Certain chemicals may have environmental concerns, especially in the groundwater contamination areas. Okay. So the conclusion of this chemical stabilization process is that chemical stabilization is an effective and widely used method for improving the properties of black cotton soil. Lime, cement, fly ash and other chemical agents can reduce the swelling potential, increase the soil strength and make it suitable for the construction. By selecting the appropriate chemical stabilizer and following proper application procedures, engineers can transform problematic black cotton soil into a reliable foundation for various types of construction. Geosynthetic process of stabilization. Geosynthetic is a material that is used the geosynthetic materials like the geogrids, geotextile, synthetic materials that are embedded within the black cotton soil to enhance the performance. Mainly two types of geosynthetics used in the construction, that are geogrids. These are the geogrids. You can see that these are the geogrids. The grid type of properties are there. These are laid into the soil to increase its properties. This is the most widely used nowadays, is the geosynthetic property. These geosynthetics are made of the polymers and the material which are discarded, and these had some environmental bad effects. These are used to develop these geosynthetics. Okay, so the net-like materials are provided as a reinforcement. This increases the strength. It increases the strength of the soil and load distribution. They prevent excessive deformation of the soil under loading. This is the pictorial view of the geogrids. And another one is the geotextile. This you can see the geotextile, a plastic sheet-like thing, a plastic poly sheets-like thing are used to improve the properties of the soil. These are permeable fabrics used to separate the layers of soil, improves the drainage and prevent the mixing of different soil layers. Okay, geosynthetic stabilization has done, and now it is the bitumen stabilization. Bitumen and asphalt can be mixed with the black cotton soil to reduce its water absorption and make it more resistant to changes in moisture content. Bitumen helps in binding the soil particles, reducing their ability to swell when in contact with the water. Bitumen is used as like the other chemicals like the lime, the fly ash, the cement we are using there. The bitumen is also used to stabilize the black cotton soil also. This is what it is mentioned in this slide. Next is the thermal stabilization. Thermal stabilization, in some cases heat treatment is used to stabilize the black cotton soil. The soil is heated to temperature that causes the dehydration of the clay minerals, therefore thereby reducing their tendency to absorb water and soil. Actually, what I have already mentioned, the black cotton soil is a montmorillonite structure. It's a montmorillonite clay mineral. It has the tendency to absorb the soil. Okay, it has some soil particles or the moisture. It has some moisture or water content present in these molecules. Okay, so if we dehydrate it, if we heat it in a sufficient quantity, the soil particles is dehydrated, the water content is dehydrated, and the soil particle is gets compacted. This is the thermal stabilization, the heat treatment we can say. This reduces the tendency to absorb the water and soiling. Okay, this is a kind of a stabilization process. This may be expensive, but it is effective also. This is a reinforcement technique. This is a complicated way, but it is a very useful, and it has some very good durable effect also. The reinforcement technique. Okay, reinforcement technique or soil reinforcement techniques like stone columns, soil nails, and micropiles can be employed to stabilize the black cotton soil, especially in situations where the soil has to bear heavy structural loads. This is the pictorial presentation of the soil stabilization with the reinforcement technique also. Okay, and this is the advantages of soil stabilization. These are the few advantages that increase the strength, reduction in soil shrinkage behavior, improve durability, and cost effectiveness. These all are already we have discussed in previous slides. Okay, so the increased strength, stabilization improve the soil load bearing capacity, makes it durable for the construction. Reduction in swelling shrinkage behavior by altering the soil properties. Stabilization minimizes the volumetric changes caused by moisture content. It improves its durability. It is cost effective also. It has some environmental benefits also. We are using the fly ash, that is a discarded material, that is a wasted material. We are using that fly ash to stabilize any soil, not only the black cotton soil, any soil we can stabilize with that of the fly ash. This has the environmental benefits also. It has some environmental impact also. So these all are the advantages of the soil stabilization. Okay, so the conclusion is that the stabilization of black cotton soil is crucial for infrastructural project in the regions where the soil is prevalent. No other soils is available where we have to construct on that black cotton soil. In that cases, we need to do the stabilization before construction. So the black cotton soil stabilization is very much important. Various methods including mechanical, chemical, geosynthetic stabilization can be used to mitigate the challenges posed by the expansive soil. Proper stabilization ensures safe, long-lasting construction and reduces the need for extensive maintenance or repair due to soil-related problems. Okay, this is actually the black cotton soil stabilization. Okay, so hope you have understood what is the soil stabilization and how many types of soil stabilization is there. What is black cotton soil also. This is not the whole thing, but the brief idea you have. I think you have got from this stabilization methods also. This geo stabilization of the ground improvement techniques is a whole subject there in this in the curriculum of BTech, MTech and all this. So it is a very vast field actually, and this need to address in any soil, not only the black cotton soil, in any soil we need to do this stabilization process. Hope you have understood my lecture, and thank you for listening. Hope we'll meet again in any other lecture also.